last three questions, three challenging questions. Yeah. So for question number 13, we still use the, weak solution, standard solution, strong solution. For this question, if you can do it using 8 comparisons, that's the weak solution. If you can do it in 7 comparisons, you get a standard solution. If you can do it in 6 comparisons, and both should be correct. I saw all these 3 answers in your solutions. And probably other numbers. But if I read carefully your solution details, if both correct, so for weak solution, -1 point. Zero, the full credit. But the strong solution, if correct, +2, 2 bonus points. All right, so let's look at the weak solution. Weak solution, usually we can use some simple techniques to solve it easily. So that's usually the weak solution. All right. The first subarray already ordered, x1, x2, x3, already ordered. So we leave it there. Then the last 4 elements, not ordered, but we sorted. Sorted in 5 comparisons, right? We know it. The optimal solution to sort 4-element array, 5 comparisons. All right, make it ordered. All right. Then the next step, because we have 2 ordered array, we want to find third largest we apply partial merge operation from high end. So we know third largest plus 3 comparisons. 3 comparisons. So total 5 plus 3, 8 comparisons. That's a weak solution. So for other solution, I need to study your details carefully. I follow your logic. So I need to really, I want to see the correct solution. Some students just put a few comparisons there. I cannot see your logic in your comparisons. You need to give me more discussion steps. If you only list several comparisons, no discussion, so that I do not treat it as a valid solution. Okay, that's very common in your first homework assignment. and also your midterm. I can see that's quite common. Just give me a list of comparisons, no discussion. I want to see your discussion and explanation. Because after each comparison, you have cases, right? Yeah. How do you process different cases? You need to show me. Okay? Yeah. So that's what I use to see if you really get a valid solution. Yeah. Even if the solution is not perfect, but if your idea works. Yeah. So most important thing is that your idea must work. Yeah. If I can see your idea works, then I can give you, very generous point. Yeah. Not necessarily perfect. I do not require you, you make it in a perfect way. Yeah. But if the main idea is correct, that should be good enough. Yeah. All right. Yeah. So that I need to, spend quite some time to grade the other two versions of solutions. Yeah. Weak solution very easy. Yeah. Idea is so easy. Yeah. But standard solution, strong solution, then much harder. Yeah. Usually much harder. Yeah. All right. But another thing another policy I want to use here, because after I look at all of your solutions, if I see nobody can get a standard solution correctly and a strong solutions correctly, so if I couldn't get anyone can do these two solutions, then I will treat the weak solution as the standard solution. So I will give you this 1 point back. Yeah, because if nobody can get standard solution, yeah, because if you cannot get standard solution, then nobody can get a strong solution, right? Yeah, yeah. If a standard, yeah, yeah. So if this part, not there, yeah, then I move this weak solution to a standard solution. Yeah. So I will give you full credit. Okay. So even if you use the weak solution, so I will give you full credit. Under the situation, nobody can solve in better versions of solutions. Yeah. Also true for other questions. Yeah. So I use this policy for all of our challenging questions. Okay. All right. Number 14. Yeah. So weak solution. Weak version, 13 comparisons. Standard version, 12 comparisons. Yeah. Weak version very easy, 3 ordered. Right? Yeah. So you merge the first two. Merge first two for the worst case. 3 plus 3 minus 1. You need 5 comparisons. Then you get the size is 3. Size 6. Then you merge 6 element ordered array and a 3 element ordered array. Another round, 3 plus 6 minus 1, 8. Second merge, 8 comparison. Then total, 5 plus 8, 13. Very easy. Yeah. So if you do this way, you get a weak solution, you get 3 points. Yeah. But this one you can do better. There is a standard solution better than this weak solution. So 12 comparison, you can get a full credit. Right. Here, let me show you the idea. If you do better than 12, 11, then you get a strong solution. You get 2 bonus points. If 11 comparison and your logic is correct, yeah. So your main idea is correct, then you get 2 bonus points. All right. So here, let me talk about the standard solution. Yeah. So let me draw a diagram. Three, two, one. First ordered array, second ordered array. B3, B2, B1. Third ordered array. Some students, yeah, I noticed before, yeah, so not from you, yeah, for you, yeah. So I remember some students, they try to use the similar idea from merging 2 ordered arrays. So they want to generalize our standard merge operation from merging 2 ordered arrays. Some students, yeah, because if you want to put the first element in place, those students, select minimum from 3 ordered array. Then to use 2 comparison, you can find a minimum, right? 2 comparison, then you put it. If you do in this way, you will use too many comparisons. So this method is very, too much slower. Yeah. All right. Worse than this weak solution. So you can think of, yeah, so let's do a little bit. You can see how much worse than even the weak solution. For example, in order to find the minimum, you need to use 2 comparisons, right? Yeah, because the minimum of 3 elements is 2 comparisons. You get the minimum, right? Yeah. All right. So minimum you put in place. Then you have 2 left. Then you put next together. Then another 2 comparisons, right? Yeah. So if you do that way, yeah, because this is very rough. Yeah. So every time 2 comparison, you put 1 element, 1 in place. Yeah. So definitely it's not efficient. Yeah. Because in the 2 comparisons, some of the comparisons are reusable. So here the problem is some are reusable. Some of the comparisons are reusable. So you need to consider the reusable comparisons. Right? Yeah. So if you do not consider that, every 2 comparison, every element you put in place, you need 2, but you need to put 8 element in place, right? The total 9. The last one you do not need. 8 element in place. Probably the last one. Last 2. Last 3. Yeah. The last one probably you do not need. Last one. Last round. Alright. Yeah, because last 3. Yeah, let's look at last 3 left. Last 3. Yeah. You have these 3 you put in place. 2 comparison. These 3, 2 comparison. Still 2 comparison. Okay? Yeah. Yeah. So put a 7. Alright. So we can do a little better. Yeah. 7 in place. Each one, 2 comparisons. Because last one you only have 2 elements left. So you just need 1 comparison. So 7 times 2 plus 1, 15. Yeah. So in this way, the best you can get is 15. 2 worse than our weak solution, right? So if you do that analogy, similar idea from our standard merge operation, you do, much slower than the our weak solution. Yeah, so this is not good. All right. So then I may like to use a different idea here. Yeah. So the idea is I pick 3 medians. Select these 3 medians. All right. I sort 3 median, local medians. Sort it in 3 comparisons. Yeah. So I use my first 3 comparisons to sort these 3 medians. After that, let me draw my diagram. Let me just assume A2 less than B2 less than C2. So we have this A3, A2, A1. Higher B3, B2, B1. C3, C2, C1. Ascending order. Sorted ascending order. Right. Then, what is the longest ordered chain? This is the longest ordered chain. Yeah. So let me draw this longest ordered chain. C3, C2, B2, A2, A1. All right. A3 here, B1 here, B3, C1. C1. Then we need to do insertions on these 4 elements. Insert these 4 elements into the longest ordered chain with minimum number of comparisons. Okay, yeah. All right. First, insert A3. Insert A3. Using the binary insertion. When we use binary insertion. A3. Yeah. All right. 2 comparisons, right? Because you compare the one in the middle, then one more at 2 sides. Yeah. So with two comparisons, we can insert A3 into the ordered chain. Yeah. All right. Then after that, yeah. So I need more space here. Yeah. Yeah. This page I have a lot of space. Yeah. All right. After insert A3, because we want to consider the worst case, now we grow our longest ordered chain. C2, B2. We want to put A3 here. Because when we put A3 here, we may have the worst case. We target the worst case. Why? A3 here, we have more chance for the worst case. Yeah, yeah. So you will see it. A2, A1, B1 here, B3 here, C1 here. All right. So why? Here, let me argue. Yeah. If we put A3 here, we can get a worst case. All right. Because the position for A, only two possible places you can consider with respect to B2. One is above B2, another is below B2, right? Yeah. If A3 above B2, then B3 needs to compare with one more element, yeah? Because above, then B3 also need to consider A3. If below, B3 does not need to consider A3, yeah, because below B2, but both C1 and B2 need to consider A3, right? 2 versus 1. Yeah. This side, we have two elements. This side, only one element. So, if two elements need to do more work versus one element need to do more work, definitely this is the worst case, right? Yeah. So we put A3 below B2. So we force C1, B1 to do more comparison work. That's for the worst case. All right. Then insert B1 into this order array, because B1 we only need to consider insertion into these 3 element ordered array. So that means two more comparisons. Yeah. 2 more comparisons, then the location doesn't matter. Okay? Yeah. Location doesn't matter. Yeah, just below B2, location doesn't matter. Yeah. All right. Then C1, yeah, because after you insert B1, you have 5 elements, right? Yeah. So B2, B1, yeah, even if I put it here, A3, A2, A1, and C2, C1. C1 needs to be inserted into this ordered chain, right? Yeah, 5 elements with 3 comparisons. Binary insertion, 3 comparisons, C1. Then B3, yeah, we only need to consider, yeah, there is a possibility C1 inserted here, right, after 3 comparisons. So B3, at the most, we need to consider 3 elements. So two more comparisons, right? All right. So here you can see, after we sort 3 median, yeah. So here, yeah. So I sort 3 medians, 3 comparisons. Then insert A3 2 comparison. Then B1 2 comparison. C1 3 comparison. B3 2 comparisons. Right? Yeah. So total 12 comparisons. Yeah. 3, 3, 2, 2, 2. 12 comparisons. So that's the standard solution. 12. I don't know. So if there is strong solution, 11 comparison, we can find a solution. Yeah. But we have a standard solution. Yeah. Then this weak solution, you can only get 3 points, not 4 points. Yeah. If standard solution not available, then we can move weak solution to the standard solution. That's the idea. Okay. Yeah. But now, because it's available, okay, standard solution is available. Yeah. All right. Yeah. The last one actually, there is a simple solution. Yeah. So I don't know. So I may treat it as a weak solution. Yeah. So the last one, we need to use our policy. Yeah. So, all right. So first, I set weak solution. Okay. Yeah. If I couldn't see standard solution, then I move weak solution to standard solution. All right. Weak solution. Yeah. So very simple. Here. X3, X4, X5, X1, X2. All right. Then the 3 elements, X6, X7, X8, we do 3 comparisons with X3. Okay. Yeah. So that's 3 comparisons. All right. After that, we need to consider, different cases, but we target the worst case. So we can identify the worst case easily. Worst case, all 3 elements are smaller than X3. Yeah. Yeah, because in that way, the median is the 4th smallest. Median, 4th smallest. So all below X3. Yeah. X6, X7, X8, all below. All right. So we have 5 elements below X3. So in these 5 elements, we need to find the second largest. Second largest. Second largest, so that is the 4th smallest, right? 4th smallest, second largest. All right, so we apply the formula. 5 plus 5 minus 2, so 3, so 8, 6, right? So 3 plus 6, 9. So 9 comparison, that's the weak solution. Okay, yeah. 8 comparison, standard solution. 7 comparison, strong solution. Yeah. But Yeah, I saw some students give 8 comparisons, but I need to, really go through the solution details. Yeah. If the logic is correct, so we have a standard solution. Yeah. Otherwise, so if I read all those solutions, none of them correct, yeah, it could happen. Yeah. So I mean, some students just give me a list of comparisons and no working details, no discussion on cases. Yeah. So then I do not treat as valid solution. If that happens, then I move weak solution to standard solution. Yeah. Yeah. So even if you make 9 comparisons, you can still get a full credit. Yeah. So that's the policy we will use, including the final. So final, we also use this policy. Yeah. All right. Yeah. Yeah. So that's how much I want to explain. Yeah. Although I have some part of some topic, some notes left in part B. Yeah. But I feel, at this time, so probably I let you focus on the homework assignment number 2. Okay. Yeah. So part B, I only give you questions in part A. Yeah. So module 5, the content of module 5. So I only do it in part A. As our quiz number 5. Part A is our quiz number 5. Yeah. So I'll give you a few questions there. So then, in computation questions, part B, C. Yeah. So we have 2 parts. Part B and C. Yeah. So you only have module 4 questions. Yeah. So you don't need to worry about module 5. Yeah. Because we do not have time. Yeah. So my old plan, I want to give you a few examples in module 5. Then I can give you a few questions. But I feel, we don't have that much time to do it. Yeah. Yeah. So I just, simplify. So I do not put a computation question from module 5. Yeah. So you focus on divide and conquer, module 4 questions in the final. Yeah. Yeah. All right, so that's pretty much I want to cover in the review session. Yeah. So do you have any question really regarding the final exam you want to ask me? The last chance, you can ask here. Yes. I can't remember. Yes. Yeah. Open. Oh, you can bring a laptop. All right. Yeah. Everyone. You can bring your laptop to access all of our course materials. Yeah. Assignments, solution files, everything from this class you can access. But when you use your laptops, I want to set rules like this. All right. Yeah. So you can, when you use internet, so mainly you access Canvas. That's legal. So if you look at the materials I post in Canvas, that's legal. Yeah. Another legal operation is if you use online calculator, then I also treat as legal. Okay, you can use online calculators if you need. Yeah. All right. But you cannot use search engines, any AI tools, and communication software. All right, so that part not legal. Yeah, so you know that's my basic rules. So no communication software you can use, and AI related technical forum you cannot use. Online forums, yeah. Other than that, so basically just our course materials. Okay, yeah. So that's our policies. Yeah. Notes, that's no problem. Yeah. Yeah. Other questions? If not, so then we just stop right here. Then just see you in the classroom Wednesday.